welcome to our answer session. This is Quants 12, which deals with correlation and regression. Uh, just before we get into the solutions to the various problems, let me tell you that correlation is the study of the degree of relationship between two variables if a relation exists, whereas regression is the study of relationship between the variables. For example, if y is the dependent variable and x is independent variable, the linear relationship suggested between the variables is called the regression equation of y on x. And here the parameters are determined using the principle of least squares. Now let us move on to the first question, which says scatter diagram is used for 1. The various options are A, B, C and D. So the question scatter diagram is used to know the nature of correlation between two variables. That is, to what extent or the degree the relationship between the two variables exists. So the correct option is C option, which says know the nature of correlation between two variables. Scatter diagram is used to basically know the relation and nature of correlation between two variables. So C is the option as per our PowerPoint diagram. This is as per our definition of scatter diagram. Second question, correlation coefficient is, out of the 4 options given, it is the B option, which says free from unit of measurement. This is the most appropriate answer for the question correlation coefficient. It cannot be in terms of units of measurement of the two variables. It's not a relative measure. It's not an absolute measure. So the only closest or a correct answer is option B, which says free from unit of measurement. Correlation coefficient is B option, which says free from unit of measurement. Moving on to third question, covariance and correlation between two variables are, we need to pick out one of the options which are correct. So going to our work area, we know that by definition correlation of x comma y is covariance of x comma y divided by sigma x into sigma y. We know sigma x and sigma y being the standard deviations of x and y is always treated as positive. Okay, therefore correlation of x comma y and covariance of x comma y both are always positive or both negative. So the answer is option C. Going back to our PowerPoint presentation, it is C option, which says both positive or negative. Fourth question, the profits in an insurance company and the number of claims have. We need to find what type of relationship the parameter profit and the number of claims have. Profits of the insurance company to the number of claims. The answer is a negative correlation. The reason being, if many deaths occur, then profits in an insurance company reduces, and vice versa. If there are less claims, then the profits tend to increase in an insurance company. So going by the option, it is B as per PowerPoint presentation. So the answer is a negative correlation exists. So B is the answer or the option. Fifth question, which says shoe size and intelligence. We would like to know the correlation. So shoe size of an individual and the intelligence, we need to know the correlation. It is totally not correlated or uncorrelated, because the size of an individual shoe has no bearing on his intelligence. So going by the PowerPoint presentation option, it is C, which is uncorrelated. C question, which says correlation coefficient is unaffected by. Actually, correlation coefficient, we all know, is equal to covariance of the two variable divided by the standard deviation of the individual variable divided by the product of the standard deviation of, say, x into standard deviation of y. Now covariance is not affected by shift of origin or change of origin. So also the standard deviation, because covariance is nothing but a square of a standard deviation if it's a single variable. So neither the covariance nor the standard deviations are affected by change of origin. So correlation is unaffected by change of origin. So the option is A, which says it is unaffected by change of origin. When seventh question, when R is equal to 1, all points in the scatter diagram will lie on a straight line directed from lower left to the upper right. This is how, because R is nothing but correlation coefficient. So if it is equal to 1, it is perfectly and positively correlated. So you get a straight line directed from lower left to the upper right. So the answer is A option, which says a straight line directed from lower left to the upper right. Eighth question, if the coefficient of correlation is 0.6, then the percentage of variation unaccounted for is, going to our work area, given R, which is nothing but coefficient of correlation is 0.6, percentage of variation unaccounted for is, as per definition, is equal to 1 minus R squared multiplied by 100 expressed in percentage. So which works out to 64%. So the answer is option D. Going back to our PowerPoint presentation, it is option D, which says is equal to 64. Ninth question, if the two regression lines are perpendicular, then the coefficient of correlation, as per definition, works out to R, which is the coefficient of correlation, will be equal to 0, or as per the PowerPoint presentation, the answer is D, or option D option, which says it is 0 or it is not correlated, uncorrelated. 10th question, the limits for the coefficient of correlation by the method of concurrent deviation, as per the formula and the definition, RC, which is called the coefficient of coefficient of correlation by the concurrent method, that is RC, will lie between -1 and 1, including -1 and +1. That is the B option, which is nothing but -1 less than or equal to RC less than or equal to 1, which is the B option. 11th question, if there is a perfect disagreement between the marks in QT, that is quantitative techniques, and accounts, then the coefficient of correlation is, that is R, should be equal to 0, or because they are uncorrelated, both of them, QT and accounts. Since they are in perfect disagreement, so it is uncorrelated or coefficient of correlation R is equal to 0. Going by the PowerPoint presentation, it is C option which says it is 0. 12th question, product moment correlation coefficient is defined as C option which says covariance and the product of variance of the two variables as given in the it is product moment correlation coefficient is defined as the ratio of what do you call the covariance and the product of the standard deviations of the two variables. So B option is the right option, which is the correlation coefficient. Covariance, and it is the ratio of covariance and the product of the standard deviation of the two variables. 13th question, the regression lines are derived by the B option which says least squares, because it is a method for finding the nearest value of a relationship, a nearest value mechanism, so that it lies closely to a given line, which is the regression line, the scatter diagram of both of two variables x and y. So the answer is B option, which says least square. B option, least square method. 14th question, the slope of the regression line of y on x is given by r into sigma y by sigma x. This is as per definition. So as per PowerPoint, the answer is A option, which says r into sigma y by sigma x, that is coefficient of correlation into standard deviation of y by standard deviation of x, that is y on x, slope of the regression line. So the option is A, which says r into sigma y by sigma x. 15th question, the correlation coefficient between x and y is given to be 0.6. The correlation coefficient between minus 2x and 6y needs to be calculated. Going to our worksheet, work area, given correlation of x comma y equal to 0.6. Now to find correlation coefficient between minus 2x and 6y, which is correlation of minus 2x comma 6y will be minus 2 into 6 divided by mod of minus 2 into mod of 6 into correlation of x comma y. So which works out to be minus of the correlation of x comma y, which is minus 0.6. So the answer is option C. Going to our PowerPoint presentation, which says option C, which is minus 0.6. 16th question, the correlation coefficient between x and y is given to be 0.54. The coefficient of correlation between x and 2 minus 3y. Going to our work area, correlation of x comma y is given to be 0.54. Now correlation of x comma 2 minus 3y will be, as per definition, is 1, that is the slope of x, which is 1, and the coefficient of x 1, and the coefficient of y here is minus 3 divided by mod of 1 into mod of minus 3 into correlation of x comma y, which is equal to minus of correlation of x comma y, which is minus 0.54. So the answer is option D. Going to our PowerPoint presentation, it is option D, which says it is minus 0.54. 17th question, which says the coefficient of correlation between x and y is given to be 0. 0.4. We need the percentage of the unexplained variation. Going to our work area, coefficient of correlation between x and y is given to be 0. 0.4, that is r equal to 0. 0.4. The percentage of the unexplained variation is given by 1 minus r squared in terms of percentage, which works out to 84%. So the answer is option D. Going to our PowerPoint presentation, which says D option, or 84%. 18th question. If values of pairs of variables x and y are given below, the coefficient of correlation between x and y needs to be found out. Going to our work area, the value of pair of x and y are as follows, as given here in the question itself. Now, based on the way y varies in correlation to x, we find that y is 3 times x, or 3x form. Since y is directly proportional or related to x, that is, they are perfectly correlated, and also positively correlated, so r is equal to 1. So the answer is option B. Going back to our PowerPoint presentation, so the option is B, which says r is equal to, or the coefficient of correlation is equal to 1. 19th question. If the regression coefficient of y on x and x on y are minus 0.9 and minus 0.4, the correlation coefficient between x and y is worked out in the worksheet as follows. Given y on x, which is nothing but byx, equal to minus 0.9, regression coefficient of x on y, bxy, equal to minus 0.4. So correlation coefficient in general is defined as the square root of the product of regression coefficient of y on x and regression coefficient of x on y. If both of them are negative, then correlation coefficient of x comma y would be also negative. So after taking the square root of the product of these two regression coefficients, we need to add one negative sign. That is, here both regression coefficients are negative, so correlation coefficient should also be negative. So it is minus 0.6. If both correlation coefficients are positive, then the correlation coefficient between x and y will also be positive. Here it is negative, so the answer is minus 0.6. Our answer is option D. Going to option, it is D option, which says minus 0.6. 28th question. If the rank correlation coefficient in two subjects for a set of students is 0.6 and the sum of the square of the difference in the ranks is 66, the number of students in the set. Going back to our work area, rank correlation coefficient rho is equal to 1 minus 6 sigma d squared by n into n squared minus 1, where n is the difference in the rank of the corresponding pairs, n is the number of items or observation. Here it refers to the students. So substituting the value for the various variables, we get 0.6 equal to 1 minus 6 into 66 by n into n squared minus 1, and on simplification we get n equal to 10, or the number of students in the set is 10, or C option. Going back to our PowerPoint presentation, it is C option, which says it is 10. 21st question. The coefficient of correlation for the following data x and the corresponding y value are listed. That is 3, 2, 5, 8, 10, 15, 12, 17, 6, 10 and 10, 12. And the coefficient of correlation is given to be r for that distribution. Now we need to find the coefficient of correlation of the data given below, where U and V, where it follows as 8, 8, 10, 14, 15, 21, 17, 23, 11, 16, 15, 18. Based on the observation, we find that uh, given that coefficient of correlation being of x and y being r, we need to find coefficient of correlation of u comma v. Now, based on the observation of the distribution of data, u is related to x by the formula u equal to x plus phi, and v is equal to y x plus, y plus, x plus 6. So what happens is basically is this is the observation we get based on the observation of the data given. We know change of origin will not affect correlation. Therefore, correlation of u comma v is equal to correlation of, rather, v is v is equal to y plus 6. And now we know change of origin will not affect correlation. Therefore, correlation of u comma v is equal to correlation of x comma y, which is equal to r. So the answer is option D. Going to our PowerPoint presentation, it is option D, which is R. 22nd question. The coefficient of correlation between x and y when they take values as given below. Going back to our worksheet, work area, where x and y, the distribution is for x equal to 7, y is minus 4, 6 it is minus 12, 4 it is minus 8, 2 it is minus 4, and when x is 1, y is minus 2. So the relationship straight away boils down to y equal to minus 2x form, which is, this is the graphical thing. Now this is perfectly correlated, but only thing, it is negative, in the sense as x increases, y as x increases, y also increases negatively. So r value, or the coefficient of correlation r, is minus 1 as per our definition and also the assumptions and other factors. Now going by the answer, it is A option, which says it is minus 1. 23rd question. If the coefficient correlation between x and y is given to be 0.6 and u and v are variables connected by the equation u equal to minus 3x plus 5 and v equal to 7y plus 6, the correlation coefficient between u and v is worked out as follows. Given that correlation coefficient of x comma y is 0.6 and u is equal to minus 3x plus y, v equal to 7y plus 6, then correlation coefficient of u comma v is equal to minus 3 into 7 divided by modulus of minus 3 into modulus of 7 into correlation of x comma y. Now they get cancelled, but a negative sign alone is left out, and the correlation of x comma y is 0.6. So the answer is minus 0.6 is the correlation coefficient of u comma v, or the answer is option A. Now we go back to the PowerPoint presentation, which says it is option A, which is minus 0.6. 24th question. If x and y are correlated variables with regression equations 3x plus 5 plus 5y plus 10 equal to 0 and 6x plus 4y plus 7 equal to 0, then the correlation coefficient is worked out as follows. Having written that, the point to be noticed to be noted is the regression coefficient with y on x and x on y should be chosen in such a way between the equation that the product of these two should not become greater than 1. Okay, so we take y here equal to minus 3 by 5x minus 2 and we get byx, that is called regression coefficient of y on x equal to minus 3 by 5. Similarly, from the other equation we get regression coefficient of x on y equal to minus 2 by 3, and by definition and by the statistics formula on regression we have correlation coefficient squared, that is r squared equal to bxy into byx, which is equal to minus 2 by 3 into minus 3 by 5 equal to 2 by 5, that is 0.4. It is to be noted r bxy byx should be of same signs. So here byx and bxy are both negative, so r, which is equal to root of 0.4, should be taken with a minus sign. So r value is minus root of 0.4. So the answer is option B. Going back to our PowerPoint presentation, it is option B, which says minus root of 0.4. 25th question, if the coefficient of concurrent deviation is minus 1 by root 3 for 10 pairs of observation, the number of concurrent deviation is worked out as follows in the work area. Coefficient of concurrent deviation RC is equal to minus 1 by root 3. Now n, the number 10 pairs, the number of observation. Capital N is nothing but n minus small n minus 1, which is equal to 9. So coefficient of concurrent deviation is RC equal to plus or minus root of plus or minus 2C minus capital N by N. Now when you try to simplify, we get C equal to 6. It's just option C. Going back to our PowerPoint presentation, the number of concurrent deviation as per the question is option C, which is option C, which is 6. So 6 is the answer, or option C. 26th question, the equation 2x plus 3y equal to 10 and 4x minus 7y equal to 15. We'll try to see which of the options satisfy. Now, going to our present work area, 2x plus 3y equal to 10 and 4x minus 7y equal to 15, we can find that regression coefficient of x on y is minus 3 by 2, while y on x, byx, is 4 by 7. Now, one of them is negative, another is positive. So your r squared, which is bxy into byx, gives a negative value. But r squared cannot be negative. So the only relevant option is D. We can see that. So it is none of these, or a D option. Going by our PowerPoint presentation, D is option, so none of these. 27th question, in the regression analysis, the sign of R, byx and bxy, all three will be of the same sign. That is, answer is option A, or same. 28th question, the sign of the correlation coefficient depends upon the sign of covariance of x comma y, because by definition correlation coefficient is nothing but covariance of x comma y divided by the standard deviation of x into standard deviation of y. We all know standard deviation of x and standard deviation of y are always positive. So the sign of the correlation coefficient depends upon only on the sign of covariance of x comma y. So the answer is covariance of the x comma y, option A, which says covariance of x comma y. If 29th question, if the two regression coefficients are positive, then going to our work area, given bxy is greater than 0 and byx greater than 0, we know then arithmetic, we also know that arithmetic mean is always greater than or equal to geometric mean greater than or equal to harmonic mean. That is, arithmetic mean is greater than or equal to harmonic mean if the sequence is positive. Arithmetic mean of bxy and byx is equal to bxy plus byx by 2, while harmonic mean of bxy and byx will be 2 times bxy into byx by bxy plus byx. Therefore, bxy, applying that famous concept, arithmetic mean greater than or equal to harmonic mean, we get bxy plus byx by 2 greater than or equal to 2bx by bxy plus byx. That is, bxy plus byx is greater than 4 times bxy into byx by bxy plus byx. That is, this will be also greater than bxy plus byx will be half of the other value on the right hand side, that is 2 times bxy into byx by bxy plus byx. So the answer is option C. Going to our PowerPoint presentation, it is option C, which says byx plus bxy greater than or equal to 2 times byx into bxy by byx plus bxy. 30th question. The coefficient of concurrent deviation for p pairs of values is 1 by root 3 and the number of concurrent deviation is 6. Then the value of p is worked out as follows. Coefficient of concurrent deviation RC is equal to 1 by root 3. Now number of concurrent deviation, that is C, is equal to 6. We need to find the number of observation P. Now RC is equal to plus or minus root of plus or minus 2C minus n by n. Now after substituting, since RC is positive, the right hand side in that plus or minus case we take only the plus, so when you square it you get 1 by 3. Here we'll get 2 into 6 minus n by n, so n works out to be 9, but we know n is equal to p minus 1, the number of observation minus 1. So p value is n plus 1, which is equal to 10. So the option is C. Option is C. Going to our PowerPoint presentation, option C is the answer, which is equal to 10. 31st question. If the rank correlation coefficient is 2 by 3 and the number of pairs of observation is 8, then sum of the square of the difference in ranks. Going to our work area, rank correlation coefficient rho is 2 by 3, given n, number of pairs of observation is 8. We need to find sigma d squared, which is sum of squares of difference in rank. We know rho equal to 1 minus 6 sigma d squared by n into n squared minus 1. Substituting the appropriate value, rho equal to 2 by 3 and n equal to 8, we can find out sigma d squared equal to 28. So the option is C. Going to our PowerPoint presentation, It is C option, which is 28. 32nd question. The sum of the squares of the deviation for 10 pairs of values x comma y from their mean are 40 and 90 respectively, and the coefficient of correlation is given to be 0.4. Then the covariance need to be found between x and y. Going back to our work area, now summation from 1 to 10 x minus x bar, that is the mean, whole squared, is given to be 40. That's what is mentioned. That is, now the number of observation is 10. So therefore the standard deviation sigma x will be given by square root of sigma x minus x bar whole squared by n, which works out to be square root of 40 by 10 equal to 2. Similarly, summation from 1 to 10 y minus y bar whole squared is equal to 90. That's what is given. Now standard deviation of y will work out to be square root of sigma y minus y bar whole squared by n, which is equal to root of 90 by 10 equal to 3. So the coefficient of correlation R is given by the standard formula covariance of x comma y by sigma x into sigma y. That is, coefficient of correlation is 0.4 given, so covariance of x comma y by standard deviation of x into standard deviation of y, which is 2 into 3. Therefore covariance of x comma y, when you cross multiply, you get it as 2.4. So the option is A. Going to our PowerPoint presentation, it is option A, which is 2.4. 33rd question. Rank in x and y are given. X increases in steps of 1, 2, 3, 4 up to 10, whereas y decreases from 10 up to 1, corresponding value. Now we need to find the sum of the square of the difference in ranks has to be computed. Going back to our work area, when you list it, the difference in rank between x and y would be 9, 7, 5, 3, and then it will start increasing. Okay, so the square of this difference would be 9 squared, 7 squared, 5 squared, 3 squared, 1 squared, again 1 squared, 3 squared, 5 squared, 7 squared, 9 squared. So when you square it individually, 81, 49, 25, 9, 1, 1, 1, 9, 25, 49, and 81. And when you add all these things, that is the sum of the square of the difference in ranks, will give you the total, that is 330. So the answer is option A. When we go back to our PowerPoint presentation, it is option A, which is 330. 34th question. If the correlation coefficient between two variables x and y is 0.6 and one of the regression coefficient is 2 by 3, the other regression coefficient has to be found out. Going to our work area, correlation coefficient R of x and y is 0.6 given, and one of them, say bxy, that is regression coefficient of x on y equal to 2 by 3, then we need to find the other one, that is regression coefficient y on x, that is byx, has to be found out. We know the relation r squared is equal to bxy into byx. So substituting the respective value, we find that byx will be worked out to 0.54. So the answer is option C. Going back to our PowerPoint presentation, it is option C, which says 0.54. 35th question. The coefficient of correlation is 0.9 from a sample of 25 pairs of items. The value of the probable error is worked out on following basis. R is 0.9, n number of pairs of observation is 25. So probable error, there are two formulas, 2 by 3 into 1 minus r squared by root n. Another one is 0.6745 into 1 1 minus r squared by root n. If we use the first formula, we get probable error as 0.0253, whereas if we use the second formula, we get value as 0.025631, exact as option A. So the answer is option A. Going back to PowerPoint presentation, the option is A, which says 0.0256. 36th question, the coefficient of rank correlation of the marks by 10 students in two particular subjects was found to be 0.5. It was then detected that the difference in ranks in the two subjects obtained by one of the students was wrongly taken as 3 instead of 7. The correct value of the rank correlation coefficient is, going by the work area, the rank correlation coefficient rho is equal to 0.5, n number of observation 10. Now wrong value in difference in rank is 3, one of the wrong values. Then the correct value in difference in rank is equal to 7. Now we know that rank correlation coefficient rho is equal to 1 minus 6 sigma d squared by n into n squared minus 1. Substituting the appropriate values for n equal to as 10 and rho equal to 0.5, and we find that sigma d squared, the summation of the difference in ranks square, the summation of the square of the difference in ranks of the two variables will be equal to 0.5 into 10 into 99 by 6, which works out to 165 by 2. Actual correct sigma d squared will be 165 by 2, and we try to pull out that particular wrong value. So since it is squared, the wrong value is 3, so it is squared. We remove the square value of that wrong value, that is, we subtract 3 squared, and the correct value is 7, difference in rank, so the square of that will be 7 squared. So it works out to 245 by 2. Now we know that sigma d squared is 245 by 2. So the actual correct rank correlation coefficient rho is equal to 1 minus 6 into 245 by 2 divided by the same 10 observations. So 10 into 99, which works out to approximately 0.258. So the answer is option C. Going back to our PowerPoint presentation, option is C, which is 0.258. 37th question, from regression equation 2x plus y plus 1 equal to 0 and 3x plus 2y plus 7 equal to 0, the correlation coefficient needs to be calculated. Going to our work area, 2x plus y plus 1 equal to 0, we have x can be rewritten as equal to minus half y minus 1 by 2, and 3x plus 2y plus 7 equal to 0, y equal to minus 3 by 2, x minus 7 by 2. Now regression coefficient of x on y, that is bxy equal to minus 1 by 2, byx similarly will be equal to minus 3 by 2, that is regression coefficient of y on x. Now r squared is equal to bxy into byx, which is equal to minus half into minus 3 by 2, which is equal to 3 by 4. So r should also be taken as negative value because bxy and byx are negative, so r will also be negative, so which is equal to minus root 3 by 2, which is, the answer is option D. Going back to our PowerPoint presentation, it is option D, which says minus root 3 by 2. 38th problem, if ax plus by plus c equal to 0 and bx plus ay plus a is equal to 0, given b is greater than a are the two regression lines, the coefficient of correlation needs to be calculated. Now if you see, since b is greater than a, we write the equation ax plus by plus c equal to 0, then we calculate y equal to, we write it as y equal to minus a by b x minus c by b. So here the regression correlation a regression coefficient of b of y on x will be minus a by b. Similarly, on the second equation, bx plus ay plus a equal to 0, it is x equal to minus a by b, y minus a by b. Here the regression coefficient of x on y is also minus a by b. So r squared will be minus a by b into minus a by b. Therefore, r will be minus a by b, because both the regression coefficients are minus a by b. So r will also be minus a by b. So the answer is option A. Going to our PowerPoint presentation, the option is A, which says minus a by b. 39th question. If a1x plus b1y plus c1 equals 0 and b2x plus a2y plus c2 equals 0 are the regression lines of y on x and x on y respectively, the coefficient of determination is found as follows: a1x plus b1y plus c1 equal to 0. So y is written as minus a1 by b1 x minus c1 by b1. Similarly, b2x plus a2y plus c2 equal to 0. Now the x is written in terms of y, which is minus a2 by b2 y minus c2 by b2. So the coefficient of determination is nothing but r squared, which is equal to byx into bxy. We know that y is expressed in the first case, y is expressed in terms of x. So coefficient of regression coefficient will be equal to byx, which is minus a1 by b1, and regression coefficient of x on y is given as minus a2 by b2, that is bxy. So minus a1 by b1 into minus a2 by b2, which is equal to a1 a2 by b1 b2. So the answer is option A. Going to the PowerPoint presentation, it is option A, which says a1 a2 by b1 b2. 40th question. If each value of a variable x is multiplied by 3 and each value of another correlated variable y by 4, the ratio between the old and new correlation coefficient is, as said, x's value is multiplied by 3 and each y value is multiplied by 4. Now new correlation, that is of 3x and 4y, is equal to 3 into 4, because that are the these are the coefficients of the new x and new y, divided by absolute of 3 into modulus, that is absolute of 4, into correlation of x comma y. So the ratio of the old correlation coefficient to new is 1:1. So the answer is option A. Going to our PowerPoint presentation, it is option A, which is 1:1. 41st question. To each value of a variable x, 5 is added, and to each value of a related variable y, 10 is added. Now the ratio of the new and old, actually it is not regression coefficient, it is correlation coefficient. We need to calculate. We know that whenever there is a shift in origin, x has been added by 5 and y has been added by 10, there will not be any change in the regression coefficient. So actually it is the corresponding regression coefficient in the old and the new will not change. So the ratio will be 1:1. Actually it should be correlation coefficient, which is, so there is no change, so the ratio is 1:1. So the answer is option A, which is 1:1. 42nd question. Standard error of the correlation coefficient is 1 minus r squared by root n, or option B, which says 1 minus r squared by root n as per definition. So option B, 1 minus r squared by root n. 43rd question, if bxy equal to minus 0.3 and byx is equal to minus 1.2, then the coefficient of correlation needs to be evaluated. bxy is minus 0.3 and byx is minus 1.2. R squared is given by the standard formula bxy into byx, so which is equal to minus 0.3 into minus 1.2, which is 0.36. Since both bxy and byx are negative, r has also to be negative, so it is minus 0.6. R squared is 0.36, r will be 0.6 because bxy and byx are negative, r will have to be negative, so it is minus 0.6. So the answer is option D. Going back to our PowerPoint presentation, it is option D, which says r equal to minus 0.6. 44th question, if x and y are correlated variables, rxy is equal to 0.92 and u equal to 3x minus 5 and v equal to minus 4y plus 7, then ruv need to be calculated. Now rxy is given to be, that is coefficient of correlation with between x and y is 0.92 and u is given by u and v are given by the following equations. We need to find the correlation coefficient of u and v, which is given by the formula. As per the formula, it is the coefficient of the of x in u. In the u equation, the coefficient of x is 3 and the coefficient of y in the equation for v, which is minus 4, divided by the absolute value of 3 into absolute value of minus 4 into correlation coefficient of x and y, x comma y, which is equal to, you get on simplification as minus 0.92. So the answer is option B. Going back to our PowerPoint presentation, it is option B, which says minus 0.92. 45th question, the covariance between two variables x and y is 72. The variances of x and y are 144 and 81 respectively. The coefficient of correlation needs to be calculated. We know covariance x comma y is 72, variance of x is 144, means standard deviation of x will be square root of that, which is 12. Variance of y is 81, means standard deviation of y will be square root of 81, which is 9. So using the formula, coefficient of correlation r is equal to covariance of x comma y by sdx into sdy, which is 72 by 12 into 9, which is 2 by 3. So the answer is option C. Going to our PowerPoint presentation, it is option C, which says 2 by 3. 46th question, for the following data, the coefficient of correlation needs to be computed. We see as x keeps decreasing, y is increasing. So the value of r is equal to minus 1, because as x decreases, y increases. So the correlation r will be equal to minus 1, or the answer is option C, which is equal to minus 1. 47th question, for the following data, in the first pair x and y, the data is given, their correlation coefficient is 0.93. We need to find the correlation coefficient between u and v, where u and v are given as follows. Now you see u is can be expressed as x plus 10. That is, you have to add 10 to each data value of x. Similarly, for v is correlated, is expressed in terms of y, means it will be v equal to y plus 6. That is, every v value is adding 6 to the y value. So what we see is u is equal to x plus 10 and v is equal to y plus 6. Now the correlation coefficient in the original x and y is 0.93, whereas in u and v there is only a shift of origin. U is shifted by 10 of x and v is shifted by 6 of y. So this correlation is never affected by a shift of origin. So RUV, or the correlation coefficient of u and v, would be the same as x and y, which is 0.93. So the answer is C option, which says 0.93. 48th question. If covariance of x comma y is 25, then the standard deviations of x and y satisfy which of the following condition? Going to our work area, covariance is given to be 25. We know that minus 1 is less than or equal to the correlation coefficient R of x comma x and y, and that is again less than or equal to 1. So when we substitute for correlation coefficient as covariance of x comma y by standard deviation of x into standard deviation of y, we have minus 1 less than or equal to, and substituting the value for covariance 25 by sdx into sdy, standard deviation, less than or equal to 1. As sdx and sdy are always positive values, we can multiply across the inequalities. So we get minus of sdx into sdy less than or equal to 25, and which is less than or equal to sdx into sdy. That is, sdx into sdy is greater than or equal to 25. So the answer is option D. So out of the options provided, the last option, that is the D option, which says the product of SDs of x and y is greater than 25. D option, the product of SDs of x and y is greater than 25. 49th problem. If x and y are variables related by 3x plus 7y minus 20 equal to 0, we need to calculate the correlation coefficient between x and y. Now it is given by a single equation. So if you write x in terms of y, then we have the regression coefficient as of x on y will be equal to minus 7 by 3. And similarly, if you write y in terms of x, then regression coefficient of y on x will be minus 3 by 7. Since both bxy and byx are negative and their product happens to be 1, so r squared will be 1. So r will also be the same sign as bxy and byx, which is minus 1. So the r value is minus 1, or the answer is option B. Going back to PowerPoint presentation, the option is B, which is minus 1. 50th question, the last one. If the regression coefficient of y on x is 4.56 and the coefficient of non-determination is 0.24, we need to calculate the regression coefficient of x on y. Going to our work area, that is regression coefficient y on x, that is byx, is given to be 4.56. Coefficient of non-determination is 0.24. We need to find coefficient of regression coefficient of x on y need to be found. We know that 1 minus r squared is equal to 0.24, where r is the coefficient of correlation coefficient. So r squared will work out to be 0.76. Now bxy into byx, these are the regression coefficient on x on y and y on x, is equal to, product is equal to 0.76, that is r squared. Now bxy we need to find. Now byx we substitute as 4.56 and r squared is 0.76. So bxy on computation gives us 1 by 6. So the answer is option C. Going to our PowerPoint presentation, it is option C, which says it is 1 by 6. Thanks for your patient hearing as we come to the final session on correlation and regression. For any further doubts or queries, please email to queries@greymatteracademics.com. Thanks for your patient hearing. Bye.